Hey everyone, welcome back. I hope you had a wonderful spring break. We're going to get right back into, I know it's weird, but we're going to jump back into quarter four, even though we just did quarter three IAs. So back into quarter four, and today we're going to build off what we learned about 2 weeks ago. So we're going to do a quick refresher first. And if you have not already, go complete your attendance assignment. It will also have some practice, refresher, remind yourself of transcription and translation, because that's what we're going to build off today. So let's jump in. Again, if you haven't already done your attendance assignment, go do that first. Oops. All right, ladies and gents. Today, we're going to start with our riddle. Thinking way back to 2 weeks ago, it was, I have hands, but I cannot clap. Who am I? I am a clock. Clocks have hands, but they cannot clap. Today's riddle is, which word is written incorrectly in the dictionary? Think about that one. So just to jump into a little review. Before we started IAs and before we did review, we were talking about the central dogma theory, and we were talking about this process of transcription and translation. And the central dogma theory stated that we all start out with our DNA. We all have DNA, and DNA codes for specific things. And so our DNA is transcribed, we use transcription to turn DNA into RNA. And we turn DNA into RNA because DNA is too big to leave the nucleus, and the RNA is just a tiny small piece of your DNA. It's copied and it's carrying this information. So the RNA travels outside of your nucleus and it's going to find the ribosomes, and on that ribosomes we're going to translate the RNA into a protein. And those proteins become everything that we know of in our body. My brown hair is because my DNA says I should have brown hair. My eyes are hazel because that's what my DNA says. My protein expresses that trait. And so the phenotype, or the physical expression of our gene, is what we see. And so today we're going to look at a case study about another physical expression, except this time it's not necessarily something we can see. And so as always, you'll need your notebook and pencil or pen and that curiosity. And your notebook. So our notebook setup today, just like all the others, will be Unit 4A, Lesson 10, Sickle Cell Anemia, for 2720. I will post my notes for this after the lesson, so make sure you take your notes and you can check yours against mine. How to be successful today. So everything's in Google Classroom, as per usual. Your attendance assignment and your exit ticket are both graded on completion and participation. So that's a little different. Exit ticket's normally graded for mastery, but not today. I just want to know what you think, so make sure that gets turned in. The mastery assignment for today is going to be the PowerPoint on sickle cell anemia that you create. That's not due until tomorrow at 8:20. And I'll walk you through that later on. So today's objective, students will be able to describe how mutations can affect protein structure and function. So we're going to apply what we've learned about the central dogma theory to sickle cell anemia. And if you didn't already know, sickle cell anemia is essentially affects the way your blood cells are shaped. So if you were to look, I don't have sickle cell anemia. If you were to look in my veins and in my arteries, you'd see blood cells. Red blood cells typically have a circular shape. They kind of look like a round shape when they're kind of indented in the middle. And red blood cells, if you don't already know this, is what carry oxygen all around your body. So your heart is pumping the blood around, your oxygen is coming from your lungs into these blood cells. The blood cells also carry the carbon dioxide back to your lungs so we can exhale it. So the whole process, thinking about like cellular respiration when we need that oxygen, is coming from our red blood cells. However, if you have sickle cell anemia, which is a genetic disorder, your blood cells, instead of being this circle, kind of almost donut shape, are sickle shape. And sometimes I like to think of them like a crescent moon. It's like a sliver moon, but they are this crescent or sickle shaped blood cells. And it causes a lot of issues for people who have sickle cell anemia. What you are going to do right now is you're going to do a little research on sickle cell anemia. You're going to create a PowerPoint, and I'm going to show you now, and thinking about its relationship to the central dogma theory. So how does sickle cell anemia relate to the idea that we go from DNA to RNA to proteins, which is the expression of the trait? And so if you go into Google Classroom, you're going to see an assignment that says sickle cell anemia PowerPoint. You're going to click on it, and you are going to see a couple questions. So what is the central dogma theory? You can just go back to this video and answer the questions about it. There's only about 6 questions there. Make sure you answer them in the slide. I know a lot of you like to jazz up your slideshow. I really appreciate that. I have to look at hundreds of these, so make it your own, change it up, just make sure you answer the questions. All the questions should just go right below it in this text, type away. You can make the font bigger, you can change it again, however you want to do it. The one thing I will say is that I've talked to many of your teachers, and many of you are doing a wonderful job making sure that you're citing information, but we're still getting people cutting and pasting. Cutting and pasting is not okay. You cannot just cut and paste someone else's definition of something. You need to put it in your own words. Because you have all these resources readily available, you need to use them responsibly. So if you choose to cut and paste instead of actually try to figure out what they're saying and putting in your own words, it's going to be an automatic 0 that you cannot make up. It happened on the IAs. We're not fools. We know what's going on. So please be responsible with your use of resources. If you do quote something, make sure you cite it. Tell me where the source is. The source should not be Wikipedia. In the assignment itself, I'm just going to pull it up. I also have included a link to the CDC, which is going to talk about sickle cell. So if you want some more information, but really all you need to use is this link right here. It's called Sickle Cell Anemia Case Study. All of the information you need about sickle cell will be in this case study. So just read, take notes in your notebook so you have all the information you need. When you're done with that, make sure you press turn in. Everyone will have their own version of their PowerPoint presentation. And then that will be it. What I'm going to ask you to do now, excuse me, I'm going to ask you to pause me. Once you're done with your PowerPoint presentation, come back. There's a couple notes I want you to take, and that will be it for the day with that short exit to give. It's only one question. So pause me now. And then come back. Pause. All right, welcome back. So at this point, you should have completed your PowerPoint presentation. If you have not, please go back and do so. I wanted to go over a couple Stamp It notes about sickle cell anemia so we can build on it for the rest of the week. Sickle cell anemia, a case study we looked at, again, like I said, is when your red blood cells are different shape. So a typical red blood cell has this circular, almost donut-like looking shape to it. They flow easily through our veins and arteries because of those soft edges. Sickle cell, however, you can have it 2 ways. You can have both genes for a sickle cell. So you can get a gene from mom and a gene from dad, and you can have all crescent-shaped blood cells, just like this. Or you can have one gene from mom that's a typical red blood cell and one gene from dad or mom that is a atypical sickle cell blood cell, and you can have a mix. But the big issue with sickle cell is that they have these sharp edges. And so if you can only imagine, it's easy way to think about it is if you've ever maybe swallowed a chip and you didn't chew it all the way and it kind of feels like it's cutting up your throat. That's kind of what it's, I don't know exactly what it's like, but that's what I imagine it's like when you have a blood cell that has sharp edges that's trying to move through your veins. So it can be painful. They also, because they are not this round shape, they can get stuck and they can create blockages, which can be dangerous. People can live with sickle cell. There's many ways to manage it. There's no cure, but it's nothing that will cause you to die. But it is a genetic disorder, so it is inherited. So as we talk about sickle cell anemia today, this genetic inherited disease, we're thinking about how does it relate to the central dogma theory. And so thinking back to our central dogma theory, a gene sequence dictates the protein structure and function, in which in turn dictates the phenotype of an organism. So essentially, a lot of fancy language for saying our DNA becomes RNA, the RNA becomes a protein, and a protein becomes what we actually see. And so all of that, excuse me, is the central dogma of biology. Sickle cell anemia, however, is when the DNA has a mutation. So if we look back here, our DNA has a mutation. So an A could be a T, or a G could be a C, or a C could be an A. So something in the DNA sequence has become mutated. And so when the DNA is transcribed into RNA, we're carrying over that mutation or that error. And so then when it's translated into a protein, it's a different than what it should be. So the protein, instead of saying, well, this blood cell should be round, it's now saying this blood cell should be sickle shaped, like this. And so that's how our mutation shows up. So the mutation happens during the first step of the central dogma theory. So the physical shape of the blood cell changes, leading to a genetic disorder. And so when I asked you the question, how does sickle cell anemia relate to the central dogma theory? Well, the expression of the trait, which is the sickle cell shaped blood cell, is because the DNA during that first step, we go back here, up here, has been mutated. And so that's the big takeaway I want you to take from this. Sickle cell happens because there was a DNA mutation. And we're going to talk about mutations tomorrow and over the rest of the week, thinking about what causes a mutation, how do we prevent them, how does our body prevent them, and what happens if you can't. That's it for today. When you're done, hop over to that Google Classroom and complete your exit ticket. And have a great rest of your day. Stay safe, stay healthy, stay inside. I know it's hard, but you got this.